During this video, we're going to discuss object variables, or perhaps I should say a bit more thoroughly, we're going to look at how data is stored in memory in Java. So it might not seem at first to be as essential as some of the other things that we've looked at during this chapter, where we actually learned how to write a class, and that stuff obviously was very, very important. But this is vitally important as well. So I hope that just because you might not see the immediate effects in your coding like you would with the other things that we've learned, that you don't lack an appreciation for what we're going to look at today. It's really important and necessary for understanding how things work underneath our program in Java, and has some really interesting side effects. All right, so let's just get to it. And I guess before we can look specifically at object variables and how they're stored in memory, we have to take a step back first. And when we take a step back, we're going to look at, I guess, just how things are stored in Java, or perhaps better, I should say, the two different types of variables that we can have in Java. And that's what I should have said from the beginning. Apologize. So there are two types of variables in Java. The first type would be a primitive type, right? So primitive types are the most basic building blocks for any Java program. And we've looked at all sorts of primitives. We've looked at booleans, characters, ints, and doubles. There are others as well. There's a total of 8 types of primitives, right? And again, these do in fact serve as the very building blocks of any sort of data manipulation in Java. They're built in, they come with Java, they are called primitives. So that's the first type, and we'll look at how those primitive types are stored in memory in Java. The second type would be objects. So this is what we're looking at during this chapter. Objects are instances of classes, where classes, of course, are user-defined structures that are composed of characteristics and actions, or we know they're also referred to as instance fields or instance variables, and then methods, which are getters or setters, right? So a class is something that you would write yourself. There's others that are already built into Java as well, of course, that you can use part of the standard library, like scanners and other things like that. But for the most part, objects will be instances of classes that we'll create ourselves. All right, and they are in fact unlimited. You can create as many different classes as you would like, and it's really just up to you and your imagination. Okay, so those are the two types of variables that we'll be looking at, primitives and objects, and they do behave very, very differently in memory. It's really quite interesting. So let's just get to it. All right, we'll start with primitives. Here I have a very, very simple line of code, something we've been doing almost from day one, and I'm simply declaring an integer. I'm naming it x, or identifying it as x, and giving it a value of 5. So again, this is a variable declaration. The variable's type is an integer, the variable's identifier is x, and the variable's value is 5. On the right hand side, or in the middle of the screen, I have what this could look like in memory. Obviously there's not a red rectangle in memory if when you write the program, but the idea is in memory this is simply stored as a name value pair. So it has a name or an identifier, which is x, and a value, which is 5. Okay. Now let's add another line of code to our statement here, and we're going to now say int y equals x. What does this mean? Well, I guess we know what it means. What does it do in memory? Well, we're now going to create a second named value pair. The name of this second variable is going to be y, and the value is also 5. And this is maybe the most important piece to understand on this slide. Right? The idea is y isn't actually equal to x, although it says it is. Right? It says int y equals x, but no, it's not equal to x. The way we should read this is it's equal to the same thing as x. So x is 5. Y is also going to be 5. They're both equal to 5 in this case. All right. Now let's just do one more line of code. We're going to say now that x is equal to 7. What happens when we set x equal to 7? Well, I think we all know that the value for x simply changes to 7. What do we need to notice here? It has no effect on y, right? If I change the value of x, y stays the exact same as you would have expected. Okay? So that's how primitives work in memory. Now let's look at how object variables work in memory. All right. So for this example, I'm going to be using the rectangle class that we looked at a couple videos ago. It's a pretty basic class that we wrote. It was a rectangle. It had two properties. length and width. We had all the accessors that you would expect: get width, get length, set length. And then, of course, I think we had get perimeter and get area, but that's not real essential for what we're going to look at here. What we just need to understand is that we're going to be constructing rectangle objects, passing it two values. So we're passing it a length or passing it a width. What does this look like in memory? Well, on the left-hand side, and this is really important term, we're creating an object variable. It's not an object. R itself isn't the object. It is an object variable. The object's variable's type is a rectangle. So it is a rectangle object variable, and it has a name or an identifier. That name is R. Okay, so again, it's not the actual rectangle. It is an object variable. On the right-hand side, we have the command equals new rectangle. We should know that the new reserved word indicates that we're going to call a constructor. In this case, it's a packed constructor. It's going to construct a rectangle with the values of 3 and 4. And here, we're actually creating the object itself, right? So on the left-hand side, object variable. Right-hand side, object. It seems like an insignificant difference, perhaps, but it's not. It's really essential and something we need to know and understand. All right. So again, left-hand side, variable. Right-hand side, the actual object. So here we've constructed our rectangle with a length of 3 and a width of 4. And the last piece going on in this line of code is we have that equal sign. And when we have the equal sign, basically what we're saying is R, you refer to the rectangle object that I just created. In C++, you'll hear of the idea of pointers. It's kind of similar. In Java, you'll often hear them referred to as, well, references, right? R is referring to the rectangle that we constructed on the right-hand side. So again, this is very different than primitives. Primitives are just named value pairs. Object variables have just that, an object variable that references an actual object in memory. Okay, so let's take this a step farther. All right, well, there we go. That's just our old primitive type. Let's now take it a step farther, right? So we've got our rectangle R. It's referring to an actual rectangle object. Okay, I'm now going to say rectangle S equals rectangle R. What does this line of code do? I hope that we can see on the left-hand side, we're declaring a new object variable. Okay, I'm going to say that again because that's really essential. We're declaring a new object variable. What is that object variable's type? Well, it's a rectangle. What is its identifier? Its identifier is S. So in memory, we would now have a new object variable of type rectangle with the identifier S. Okay, now where things get a little more interesting is when we say equals R. What happens when we say it equals R? Well, I'm going to tell you first of all two things that it does not mean, and then finally what it does mean. So let's look at the first thing it does not mean. It doesn't mean that S is kind of equal to the same type of rectangle like it did in primitives, right? In primitives, if we did something like this, well, we did something like this. We set y equal to x, and what that just did was y was equal to the same value as x. It also had a value of 5. Here, we are not constructing a new object, right? You can see that doesn't say anything about new rectangle, right? It's just saying it's equal to R. But again, it does not mean that S is referring to a rectangle that's the same as the rectangle that R is referencing. And I hope I said that well. Okay, so it does not mean that. Here's another thing it does not mean. It doesn't mean that S is kind of referring to R, right? Like S is, I don't know, that's not referring to R, the object variable R, unfortunately. So I don't know if I have much more to say about that, except for that's not what it looks like. All right, here's what it does mean. It means that S is referring to the same rectangle that R is referring to. We now have two object variables, both of type rectangle. One is named R, one is named S. They're both referring to or referencing that same rectangle object. In some ways, you could think of S as being an alias or a nickname, just another way to identify that same rectangle in memory. They're both referring to the same object. Pretty interesting. Okay, so if I was to ask you, how many object variables are there now? There would be two object variables. R and S are both object variables. How many objects are there? There's just the one object, right? That rectangle with a length of 3 and a length of 4. So let's try one new piece here, okay? I'm now going to call a modifier on rectangle R, right? So you can see I'm saying R, which is the name of my rectangle. I'm calling the modifier set width, and I'm passing it 12. What would this method do? I think it's clear that we can see that it's going to change the width of the rectangle that R is referring to be 12 instead of 4. Right? So that's pretty straightforward. Here's where it gets a little more interesting. I'm now going to print out the width, or I should say S is width, right? We're going to print out the width of the rectangle S. What would this print out? I think it's clear from the picture in the diagram on the right hand side that this would print out 12, right? Even though when we, I guess, declared rectangle S, it was referencing a rectangle with a width of 4, we changed that width. So when we change rectangle R's width to 4, we're also changing rectangle S's width to 4. And I mean, the reason is quite obvious when you look at the picture. The reason that is because they're both pointing at the same rectangle. So if you change one, you change the other because they are one and the same, right? Okay, last example here, and then we'll be finished. All right, so we still have our rectangle object variables, both referring to the same rectangle object. We've changed the width to 12. Let's change their length now, okay? You can see that I'm calling the setLength function on rectangle S, okay? So I want to change the length. What am I going to set it to? I'm going to set it equal to whatever R's length is, all right? So if I was to say R.getLength, what value would that return? I think, again, we can tell pretty easily from the picture that that is going to return 3 because the length of the rectangle that R is referring to is 3. We'll then multiply that by 2 to, of course, get 6. And then we'll pass 6 to the setLength modifier. Okay, and what does that end up giving us? Well, you can see that the rectangle that both R and S are referring to or referencing would now have a length of 6 or has a length of 6. So if I was to print something like R.getLength, that would print 6, or S.getLength would also print 6. Again, not to keep saying the same thing, but that's because they're both referring to the same object, right? So that's it. I hope that helps. Again, super important concept. I find it really interesting, especially once we start getting into collections like array lists and arrays and all that sort of stuff, just to see the effects that it can have, and then we'll get into inheritance, and boy, that's where it gets really interesting. So, yeah, I hope this makes sense. Please send me an email if you have any sort of questions.